Right, in terms of air conditioning, we did say we take the hot bleed air, and you can see again the colors change here. We get the hot bleed air and we temperature regulate it, and then we distribute it, and we use it also to pressurize the cabin. Okay, these are the different functions that we've got by using bleed air to supply air into the cabin, distribute it, regulate it for temperature, and pressurize the cabin for flight at high altitude. Okay, these are the different functions, and we're just going to go through them slowly and see what we got. So we have two packs where hot air from the engines, okay, from the engines, which are on the wings, come to the packs, which are on the belly of the aircraft. Okay. And from these from these packs, we have the 200-degree air, 200-degree hot air that comes in, and out of the pack comes, see this cold air, cold, freezing cold, like 0 degrees cold. Freezing cold air goes to this mixing unit. So this mixing unit here takes this cold air, and we feed a little bit of hot air. We add hot air to the freezing cold air to temperature regulate it to the amount of the temperature the pilot has selected in the cockpit. It all happens automatically. Okay, in this mixer unit. Okay, so we're going to see the design of it in a minute, but the idea is the hot air gets delivered to the packs. What comes out of the packs is freezing cold air at 0 degrees. That's too cold to put it in the cabin. So we just add a little bit of hot air, just enough at a ratio to what the pilot has selected in the cabin. Same with the flow. If you think of your car, guys, you've got two temperature selectors on your car. You've got the amount of air that the fan goes or nothing, yeah, and the temperature. The same here. All right, so we can make high flow and high temperature, or low flow, low temperature, and vice versa. And this is what the pilot selects. Albeit the pilot selects it not only for the cockpit, but for the whole cabin as well. Okay, so there are different selectors in the cockpit for the cockpit itself and for the rest of the cabin, called zones. Okay, and we're going to see that in a minute. We also have recirculation fans. Okay, because remember, guys, we are in a pressurized vessel. We are at 35,000 feet. Okay, there are always leaks, but the leaks are minimal. But a lot of the air we're using in the cabin is recirculated air. Okay, which we have these recirculation fans in the mixer unit, which recirculate the existing air in the cabin. So it goes, all the air around the cabin comes through. There's these massive filters that filter it and send it through again into the cabin, and we recirculate it. The a large proportion of the existing air that's in the cabin. Okay, so this is a basic outline of the system in terms of the air conditioning. Next slide is an interesting one. We said how the system goes from hot air, 200 degrees, okay, which goes through two heat exchangers. Okay, so first heat exchanger and cools down a little bit, and then goes and gets compressed. This is the air cycling machine. It has a compressor on it, and a turbine on it. Okay, so the 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 hot air, 200 degrees, gets cooled down a little bit and then gets compressed. And what happens when we compress air? It gets really hot again, even hotter maybe. But we heat exchange it again. How do we heat exchange it? It's by induction. Okay. In other words, we're putting it in the stream of a cold air. This is ram air, and ram air is very, very cold. It's minus 57. Okay, so these heat exchangers they have these enormous amount of cooling fins where the cold air is distributed over a larger area, and through induction, it takes away the heat, dissipates the heat, and therefore the air temperature cools down. Then I put it through a turbine, which will then release it into the cabin at a freezing cold temperature. Okay. Now, all this is controlled by two computers, two air conditioning system controllers, one for pack 1, number 2 for pack 2, which are completely independent and switch on flow control valves, the bypass valve. If, for example, the air cycling machine was broken, completely broken, and it was seized, for example, then we would get hot air, at least, being cooled a little bit, and through here, this bypass valve would open and allow not so cold air through into the cabin, which we could then temperature regulate it, or the amount that this bypass valve allows is enough to a preset value of air in the cabin. Okay, so there are always ways to get air into the cabin. All right. So these air conditioning system controllers, we're going to see in a minute, they are an evolution of a box, of a computer, because they used to be a different system, but we'll stick with this at the moment. So we said the hot air comes from pack 1, from engine 1 into pack 1, and from engine 2 into pack 2. The ACSC, number 1, controls all the systems in pack 1, what they need to do to provide the air, okay, temperatures and everything for what the pilot has selected. And how does that work? So we have hot air come in, goes into pack 1 hot and comes out freezing cold. I also take hot air to this trim air pressure regulating valve. Okay, trim air PRV. What does this do? It mixes. So these trim air valves, they modulate. They allow more or less hot air come in, depending on what the pilot has selected, hot or cold, on their temperature selector. Okay, so the hotter they want the cabin, the more hot air these trim air valves allow to come in to mix with the freezing cold air and go to the different zones. Okay, and I can have different temperatures. You have this on cars nowadays. I can have different temperatures in the cockpit, or in the zone 1 or zone 2. Okay, because each zone, each area has its own trim air valve. All right, now this one is it's not only a trim air, master trim air valve, it's also a pressure regulating valve. Why is it pressure regulating? Because remember we said the air coming out here is at 35 psi. You can't have 35 psi coming through the riser ducts, blowing at you at 35 psi. It's too much. Okay. So what this thing does as well, it adjusts the pressure, okay, so that it's just 2 or 3 psi above ambient. So when you open that riser duct, when you open the temperature thing above your head on the PSU, it comes out at an adequate flow without blowing the toupee away. Okay, so that's the amount of air is at a comfortable sort of amount. Okay, so the amount the trim air valves open or close allow hot air depend on the amount of the temperature selected here, and the signals how much to open and close are calculated by the ACSCs 1 and 2, okay, for their respective pack. That's all there is to it, really, the air conditioning system. But I want to go back in time, okay, because before we had an ACSC 1 and 2, we had a pack controller, number 1, a pack controller, number 2, and a zone controller. And the pack controller was the brain for the pack, 1 or 2, and the zone controller was the brain for the trim air valves. So up after a certain MSN, master serial number, the manufacturer's serial number, Airbus decided, oh, we're going to get rid of this zone controller. And this zone controller, by the way, has 2 channels. Okay, and we're going to put the 2 channels, we're going to put 1 channel in this pack controller and 1 channel in this pack controller. And now we're going to change the name of this box and call it an air conditioning system controller. Okay, so by doing that, they got rid of 1 box and maybe 3 kilos of hardware. Okay, and distributed the use of the 2 channels in this box now are embedded in the respective ACSCs, 1 for system 1 and ACSC 2 for system 2. Okay, so depending on what aircraft you're working on, okay, you might be working on a really old A320. You might have, if you open the system schematics, and you'll see pack controller, and a zone controller. Or on the newer aircraft, around about, don't quote me on this, but it's around about 1600, 1800 MSN. Okay, they went from pack controller, zone controller to ACSC1, ACSC2. Okay, so you have to make sure, guys, if you're performing maintenance on the air conditioning system, you get the right effectivity aircraft, because there are different architectures. Okay, you don't want to be troubleshooting a box that doesn't even exist, because you'll end up a fool. Okay, so make sure you get the right MSN, you get the right schematic, you get the right troubleshooting entry point, and you're doing the right troubleshooting.